All right, this video is over parametric graphs. Parametrics require a third variable, which we call t. So a parametric equation is really two equations. X and y are given in terms of t. So as you see these equations, you'll see what I mean. But there's a third variable, x, y, and t, and that makes it what we call a parametric equation. So we're going to focus today on graphing these guys. So let's look at this. So here you have parametric equations. Notice x is 3t minus 3. Y is 2t. And then there's this parameters here for t. It says t is between -2 and +2. Now, graphing it is not so bad, okay? Especially when they give you this information, because this is what's going to go in your first column of your table. And you'll have 3 columns, one for t, one for x, and one for y. So this inequality tells me I need to start at -2 and I go all the way to +2. So -2, -1, 0, 1, and 2. Now for my x's, all I need to do is plug in those t values into the equation and get my x. So 3 times -2 is -6, minus 3 is -9. And then -1, 3 times -1 is -3, minus 3 is -6. 0 times 3 is 0, minus 3 is -3. 1 times 3 is 3, minus 3 is 0. 2 times 3 is 6, minus 3 is 3. All right, there's my x coordinates. My y coordinates, now same idea, just putting in t for the t values into my equation. So 2 times -2 is -4. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. And 2 times 2 is 4. All right, so now graphing this, I just focus on my x and y values. All right, so let's plot these points. At -9, I'm at -4. At -6, I'm at -2. -3, I'm at 0. X is 0, y is 2. Where x is 3, 1, 2, 3, y is 4. All right, so what I have is a line that looks like this. It's really a line segment because it begins and it ends right there. Now, the only big thing we do different when we graph parametrics, we put these little arrows on it because it's showing movement. It's moving from -2 to +2 in this direction. Okay, so we've graphed our first parametric curve. Let's try another one. All right, so there's your equations. X equals t minus 1 and y equals square root of 2t. Now, with this inequality, it's saying t is greater than 0. So I start with t being 0. All right, let's just do this one first. So if I put in a t for 0, x is going to be 0 minus 1, so -1. 2 times 0 is 0, square root of 0 is 0. Easy enough. Now, my next t values are not as clear with this inequality, and I want to think carefully about them because look what I have to do when I do y. I'm going to take a square root, and I want my square roots to be pretty, meaning I want whole numbers, I want them easy to graph. So you kind of think through this, okay? If I put in a 1 for t, 1 times 2 is 2, square root of 2 is a decimal, not good. If I put in a 2 for t, 2 times 2 is 4, okay, square root of 4 is 2. So I'm going to put in a 2 for t. Square root of 4 is 2. That's my y coordinate. So let's put in a 2 here for x. 2 minus 1 is 1. All right, let's find our next t value. All right, 2 worked. Would 3 work? 3 times 2 is 6. 6 is not a perfect square. 4 times 2 is 8. 8 is not a perfect square. 5 times 2 is 10. 10 is not a perfect square. 6 times 2 is 12. Not a perfect square. 7 times 2 is 14. Not a perfect square. 8 times 2 is 16. It is a perfect square, so I'm going to go to 8. 8 times 2 is 16. The square root of 16 is 4. All right, and if I put in 8 for my x here for t, 8 minus 1 is 7. And I could keep going, but as you can see, this would be quite monotonous if we kept doing this. So in this scenario where you have a square root for one of your equations, you really want to be strategic in your t values, okay? So we can graph this. Our x values go from -1 to +7. There's 7. Okay, and y values go to 4. 1, 2, 3, 4. All right, so graph this. At -1, y is 0. At 1, y is 2. At 7, y is 4. So what we have is this curve basically doing this. And it could go on forever because our inequality doesn't stop anywhere. It just has to be greater than 0. So I could keep on going to infinity. That's why I put the arrow on the end of my graph, because it could keep on going to infinity. All right? So you kind of see what that looks like. Let's try the next one. X equals t minus 1, y equals t squared. And t is between -2 and 2. All right, this is dictating what's going in our t column. So -2, -1, 0, 1, and 2. All right, let me start plugging it in. And my x's, -2 minus 1 is -3. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. All right, let's do the same thing for y's. -2 squared is +4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. All right, so let's graph this. X values go from -3 to +1. And my y values go from 0 to 4. 1, 2, 3, 4. All right, -3, I'm up at 4. -2, I'm at 1. -1, I'm at 0. At 0, I'm back at 1. At +1, I'm back up at 4. So look at that. It is parabola. So I'm going to draw this curve, and notice it has a beginning and an end. So it's going to end with segments, not arrows. So I connect the dots. And I put in the arrows. Which direction is it moving? Well, it's going this way here, and then it curves out. There's your parametric curve. All right? Hope that makes sense, and we'll see you in class.